sponsored by Systems Group. Do you want to say anything
we are.
Oakwood does project work? And
Yes. Yeah, we do project work, but primarily focused on the Microsoft stack. So we're looking for BI expertise as well as C# as well as work in that area. We're part of the director. Happy to go on.
And then our dinner tonight is sponsored by Concern Technology Group. We've got Keith, Aaron, and TJ. And so Keith, you want to talk a little about the company? And
thank you, Julia. I'll give you a 30-second video. Thanks so much for the invitation. Help yourself. We've got more food than we can feed anybody. We've got water as well and trinkets. Take those home to family, friends, do whatever you want with them. Azure Technology Group. Just a show of hands, who has even heard of our company? Just by chance. We are a St. Louis-based IT-specific staffing agency. We just celebrated our 5-year anniversary. I've been with the company since the beginning, along with our owner, Jay Murchison. They didn't know that name. And we've now grown to over 85 plus different clients here in St. Louis, as well as we fluctuate between 85 to 96 consultants that are working in St. Louis now. We're very proud of that. But we're making a good mark in St. Louis. We're pretty agnostic when it comes to skill set. We're hiring as well. We can certainly help if you need some help. But we appreciate the opportunity to present briefly to you, and our cards on the back table. If you ever are in the need, if you're a manager or in a hiring position, we'd love to open that door to help find you some good talent, whatever skill level that is, both on the infrastructure side and on the application side of the house, everything in between. So.
well, thank you so much for coming and sponsoring the dinner.
Oh, you're welcome.
It's really
It
appreciated.
always helps. Food.
So there's a calendar item back there, and there's an evaluation sheet, and an attendance sheet. You can check your name off, or if you can write your name in if it's not on the sheet. We will have a raffle at the end of the meeting. You got to turn your eval sheet in to get the raffle. Kathy is donating a Past Summit 2016 recordings for the USB. This is just like you there. It's got the video, the audio. It's fantastic. It's a $200 item there. And then we can have some, I still have some prototype vouchers, which we hope are still good. So the next meetings are the BI user group meeting. It's going to be November 14th. It's an afternoon meeting. It's going to be here in the same room. Yuri Bell, Competent Technology Partners, is going to be speaking on a BI topic.
Yes.
And then Sean Nasser is going to talk about the Lambda architecture. And Covenant is going to be sponsoring the lunch. We are part of the PASS, which is the Professional Association for SQL Server Community. And here's the news with that. Summit is coming up. It's October 31st to the 3rd of November. It's now $23.95, and if you use our discount code, you get $150 off. It's the premier SQL Server conference. If you have any questions about coming to it or anything, I've been there. Gary's been there. Kathy is a frequent speaker there. Just come up and ask us about it. If you can't make it this year, I think starting at the end of this year or in January, they have like the lowest price. It's like $9.95 for the conference fee. But then they have your money the whole year. So just keep that in mind. Next. Here's some hosted events that are coming up. Women in Technology is having, at the summit, Women in Technology is going to have a networking happy hour. There's school karaoke, which I think Kathy started.
I did. Yes, I can tell you the story.
It's like, she's up till 2 in the morning. I don't know how. The game night, introducer pragmatics works after party. You can read up and a meet up. And there's a link for the SQL Summit activities. These are the winners of the Board of Election results. John Martin, Shade, and Diego Nogare.
Probably Nogare.
So I hope everyone had a chance to go out and vote. It didn't look like there were a lot of past members who voted. So your vote really did count.
It really counts. If you...
Next. Virtual chapters. You're lucky we have a physical chapter here, but there's a large number of virtual chapters. You can take your past membership associated with the virtual chapter. You're getting emails about the upcoming lectures. They're usually lunch and learns. They're usually all recorded and posted on their website. So Women in Technology, in which Kathy is co-chair of, is going to have a lecture on October 18th. There's Russian, there's application development, database administration. Yeah, I enjoyed.
Saturday Night SQL looks good.
This one tomorrow.
I just decided I might be too old to learn GitHub, but look, there's a whole session on getting started. It might be good.
Yeah. That's a good idea.
Yeah.
So this is just a listing PowerShell. I mean, you name it. It's from like DBA 101 to more in detail on data science. SQL Saturdays are one-day mini conferences. We had one last year. We didn't have one this year. We're hoping to have one next year. But Kansas City had theirs recently. I know Kathy probably went.
Yeah, just this weekend.
Oh, it's
This past weekend.
Yeah, this past last weekend was Kansas City, and they always have a huge turnout with great lecturers. But it's, if there's, just keep an eye out on the SQLSaturday.com, and you'll see which ones are coming up in the area, and it's worthwhile to go to. The charge is usually only to cover your lunch. You can stay connected with Kat. And here we have Kathy. So Kathy has recently accepted the position over at Redgate. She's the editor of the Simple Talk at Redgate and the Data Platform MVP. She's worked with SQL Server for almost 20 years, which just surprised me. She doesn't look like she is, she looks very youthful.
Thank you.
And she's co-authored or tech edited over a dozen technical books. She's the co-leader of the Past Women in Technology virtual group, a volunteer at Launch Code. And when Kathy isn't working, she enjoys spending time with the family, friends, cycling, singing, that's karaoke. And we've now added climbing the stairs of tall buildings. Be sure to check out our Pluralsight courses. We have some raffle items for Pluralsight 30-day trials. So, we really appreciate Kathy being one of our speakers here and taking advantage of. I feel like we take advantage of her because she usually talks more than once in a year.
That's fine.
So you got your mic on.
I'm hoping it's on. Make sure you can hear me over there. And then we'll get started. And I'm recording already. So I just climbed. You ever heard of the Space Needle in Seattle? I just climbed that 2 weekends ago. Climbed to the top of the stairs. I believe 832, something like that. It's not as many as the Met Square building, which is what I usually do.
You have to train.
You can. You don't have to.
You don't do that kind of thing on the
No, like it was a event, a fundraising event. My daughter didn't train for it. She still did it.
But she was sorry.
She's younger.
She's in her 30s.
And it's recording.
Okay. No, if you can run a mile, you can do this. So that's what I do. So anyway, so earlier in the year, I decided it was time to get back into the real world, the real full-time job. I've been independent for 3 years, just kind of having fun, working when I feel like it, writing books, doing Pluralsight courses. And I thought, well, I don't want to go back and do the same old thing. I want to look at something new. So I started looking at data science. And when I learned how to use Azure ML, I was so excited about it. It was so much fun because like one week we had a board meeting with the past group and Sean Nesser volunteered me to do Azure Machine Learning. Well, at that point I hadn't even touched it. And I'm like, Sean, I haven't started learning that, you know. And then like a week later, I started on that class and it was so much fun. Then I immediately turned around and said, Julie, yes, I will speak on it. So it's just so cool. And so immediately when I learn something new, then I like to share it with somebody else. That's just how I am. It's just kind of crazy. And I did just recently join Redgate, so I did get the cool new job. So I start next week. I have some titles out there on APress, beginning T-SQL, beginning reporting services, and advanced T-SQL window functions, and I also have some Pluralsight courses. So I'll make sure Julie gets the slides, so you can download those slides. I got some other books out there, but those are the 3 most recent. And now Simple Talk Editor, yay! All right, so what we're going to talk about today is just tell you what machine learning is. How many of you in the room are data scientists? We have 1 data scientist. Okay, so what languages do you use for like regression and classification? Do you use Python, R?
No, I use Java.
You use Java?
Yeah.
Okay, so
SQL. I use SQL.
okay. So there's a lot of people use Python, they use R, they use C#, they use Java. There's a lot of languages out there that you can use. But Microsoft, a couple of years ago, created this new service out of Azure called Azure Machine Learning. So I'm going to explain how to do that. So we have 1 data scientist in here. Anybody else do machine learning? There's a couple of people that do machine learning, but they don't call themselves data scientists. So what kind of tools do you use?
R.
Oh, you use Azure ML? So if I run into a problem, I can go to you for help.
We'll do all together.
And then what languages or tools do you use?
R.
Use R? Okay. Okay, and ML Studio? Okay. So the cool thing about this, so if you using other languages, this might be a way to say, hey, look what's possible in Azure ML. If you're completely new to this, then this might give you a glimpse into something you might want to learn. Any DBAs in the room? Database administrators? 1.5? 1.5 DBAs. So, you know, the way that technology is moving, the skills that I have right now are not going to be really that useful or that much in demand, you know, 10 years from now. So that's why I said, hey, I need to start learning something new. So there's probably everybody in the room, if you're interested in all, if this piques your interest, you should take a look at this. And I'll show you where to find out more about data science in general and machine learning. You can start learning this on your own time for free, or if you want the big certificate, you know, of not that much money. Probably, well, I'm going to say less than $1,000 if you want the big certificate. And the price doubled, so it used to be less than that. So what is machine learning? So imagine that you are, you know, you're just on a trip. This happened to me. I was out in Phoenix, and I got this phone call from my credit card company, and they said, are you in Las Vegas? And I said, no, I'm not in Las Vegas. Well, someone is, you know, using your card in Las Vegas. So by using data science, by looking at these charges that come through and applying their secret algorithms, whatever they do, they saw something that looked like an anomaly and flagged it as possibly suspicious. I was really impressed with that because Phoenix and Las Vegas are not that far apart. And where they used my card was at a grocery store. So I was really surprised they caught that. But basically, it's a way that you can use a computer to predict what's going to happen. In some ways to use it. One way, there's a couple big classifications: supervised and unsupervised learning. So supervised learning would be like, is this credit card charge fraudulent? Yes or no? And that's classification. Okay, so if I have classification, is this yes or no, based on what they call features. Think of a spreadsheet or a table, and every column is what's called a feature in machine learning. The other is regression. Let's say I have a lot of, again, several features, and this time I'm not guessing yes or no, but I'm guessing how much. Okay, so maybe I'm going to guess what's the price of all these features of this car, based on a lot of different things. What might be the price of the car? And that's called regression. There's also unsupervised learning. So with unsupervised learning, you don't necessarily have a specific answer. For example, clustering. Let's say you have hundreds of patients, and there's 3 specific different drug regimens you might give for a specific illness. And it's based on a lot of things about the person. Well, with clustering, you take those pieces of information and figure out, how to group people or group whatever you're looking at. That one I haven't really done a whole lot with. I saw one little demo that I've played with. But basically, supervised learning, I train my model on known entities, and then I test my model on known entities, and I can keep working on that until I get it right. If I have pick one algorithm to use, then I can tweak the settings, or I can pick another algorithm that's similar, and maybe that second algorithm or maybe those tweaks give me better results. Once I'm done playing with that, then I pick the one that gave me the best results, and that's the one I'm going to publish as a service. So when I was working on my final exam in this class, I spent like 4 hours testing all kinds, I tested all kinds of things, trying to come up with the best results. And then once I had my best results, I could take the test. Basically, the test was, for this data, what's the answer? For this data, what's the answer? And you had to get a certain number of them right. And I spent probably a good 4 hours. I know it was an entire afternoon just tweaking and just playing with that, coming up with a different algorithm. So one thing I'll tell you, this interface that I'm going to show you is really easy to use, especially if you're familiar, for example, with integration services. It's really easy to learn, but you've got to have some knowledge behind it. So my favorite thing is SQL Server, obviously. SQL Server, the best thing about SQL Server is that it's really easy to install. What's the worst thing about SQL Server? It's really easy to install. Anybody can do it and make a big mess, right? So the same thing with data science. I can go in and set up a model and look like I know what I'm doing when I really don't. So again, I'm not going to teach you everything there is to know. I'm just learning as well. But I'm going to point you to some resources where you can start down this path if you want to. And so since I've got this job at Redgate, my future data science job is not going to be filled. There's still going to be that data science job that I didn't go to because I'm going to Redgate. So might be something to look at. All right, so this Microsoft says they've been in the machine learning area since 1999. Whenever they bought Hotmail from somewhere else. They didn't originally invent it or design it. And they said they worked on filtering junk mail, and that was a machine learning algorithm. And these algorithms are really not necessarily new. I suppose some of them are, but there's statistical algorithms that go way back. In 2004, they added machine learning to Bing. And I'm really interested in Bing all of a sudden because I'm reading the new Satya Nadella book. Have you heard of that? The new CEO of Microsoft just wrote a book, and I'm reading that. He was in charge of Bing originally, and he got promoted to CEO. In 2005, they added data mining to SQL Server, and I remember several user group meetings where data mining was demonstrated, but I never heard of anyone actually using it. Anybody use it for a production? No one in here. Okay, they had that. I don't know if it's still there or not. Maybe not.
You mean it's X?
Not analysis services.
That's where it used to be.
It's part of analysis services, but not complete. It's a separate little piece that you can do. Yeah, I mean, lots of people have used analysis services, but not specifically that data mining piece, supposedly. I haven't used it. In 2008, they had Bing Maps. The Connect, that's fun. Anybody have a Connect at home? Where it has the gestures, you can play the games, and it just sees what you're doing. I can't believe nobody's got an Xbox with a Connect. You got one?
We've got one that just sits there.
Mine does now. But we use it a lot. But I don't have little kids at home. But sometimes we get it out. Yeah, you can just pretend like you're bowling and dance and do all kinds of things. It's pretty fun. And so now in 2014, they came up with Azure ML. And the idea is that, remember how Microsoft, decades ago, they wanted a PC in every home and in every office desk. That was their goal. They wanted to democratize PC, democratize computing. Now they're wanting to democratize machine learning. Again, you can do more damage, a little knowledge, a lot of damage sometimes. So it's worth, I like that the interface is really easy to use, but I honestly, still feel a little nervous about it. I'm going to start using it in my new job, actually. So I'm excited about that. But, I feel like it's going to take maybe another year or two before I'm really, really comfortable with it. At least as far as knowing, understanding what all the algorithms do. So as far as most database administrators are probably going to be really comfortable with this first piece here. We are, at least I've been, or ETL developers, we are used to getting data from lots of different places, manipulating it, cleaning it up, I feel like a lot of us can already do that. And that was one of the reasons that I wanted to go into data science, is because I felt like I kept hearing that piece of it is 85%, and data scientists don't really like that part of it necessarily. And that's, I felt like, well, I can already do that. And that's a big part of the job. Well, then this other circle right here is using the algorithms, coming up with the model. And then when you finally come up with the best model, deploy that. From what I understand, I haven't been involved with machine learning really in anything else, just starting to learn it in Python right now. But from what I understand, once you even have your model, getting that deployed has often been difficult. And in Azure Machine Learning, it's very, very simple to deploy. It's like crazy simple. So I will show you how that works. So just an example of what classification is. Remember I said classification is one of the supervised types of learning. So let's say we have a bunch of data. It might be whatever the value is. And I can draw a line between the known values of true or false. So that's my sample data, what I train on. And then I supply some other values, and they're the zeros, or the O's, but notice that some of them are in red. Can you see that? It doesn't really show up very well here. Okay, so I have a red one right here that's ended up false that should have been true, and here's one that ended up true and it should have been false. So the thing with these algorithms is they are never 100%. We might get 99%, but they're never 100%. And part of this is looking at looking at the data different ways, trying to figure out just how much error there was and what we can do to improve it. You know, do we need to move that line, whatever. The other one is regression. So with regression, we've got all those red dots are variables. So in algebra, I took it in high school. I'm sure kids are now taking it in 6th grade, 5th grade. You come up with y equals mx plus b, you know, the formula of a line. Okay, so that's what you end up with regression. We have this line through here, that blue line in the middle, that we can use to predict values. So given x, can we predict y? Well, again, and there's my values. Again, it's not going to be 100%, but I can predict something that's possibly in the ballpark. So when I have data that lines up like this, I can use regression to figure out, again, how much, not true or false, but how much. This is a quote from a student who was at, now I can't remember what school he was at, got a degree, and right after his degree, he went to work for Microsoft, and that's when he found out about Azure ML, and he was just floored that he could put something together so quickly. Again, it's pretty easy to use. All right, so yeah, I'm not going to read through this. Just basically, this is kind of Microsoft marketing stuff, just talking about it's easy and there's cool things in it. So not only can I use the built-in algorithms, I can use whatever R or Python algorithms that I want to as well. I can use those in there. I can even use SQL. It's a little language called SQLite that I can use. All right, so this is what the studio looks like, and I'm going to be using Zoom. Even though I hate Zoom, I'm going to be using Zoom so we can, when we get to the demo, we can zoom in on these items, just because it's so light. But there is a nice visual editor. It's basically, anybody in here use integration services or the old DTS where you just have task or you have transform and you drag a line from one to the next? It's similar to that. So it's pretty easy to learn. And one of the cool things, let's say I want to join 2 data sets. So I'm going to import data from spreadsheets. Let's say I want to join those in some ways. I can do it with R, I can do it with Python, I can do it with join control or join task, or I can do it with SQL. I'll show you an example of that. So there's a lot of flexibility. I would assume that some of the built-in things are probably going to be the easiest to use, but maybe sometimes they don't do exactly what you want. Well, then you've got code that you can do it. All right, this is just an example of all the different algorithms they have. They have anomaly detection, classification, which is that true-false. So they've got a ton of different classification algorithms. They have clustering, k-means clustering, and they have regression. And I don't see it on here. I don't see it on this slide, but there's also recommender. So recommender would be like you go to Netflix, and when you open up Netflix, what does it always do? It tells you things that you might want to watch. It recommends things for you. So behind all of that is data science, machine learning, trying to figure out what kind of movies that you will like and which kind of movies that you will like a lot. Okay, so that's a recommender. Pretty sure there's an Azure machine learning recommender as well. All right, so there are lots and lots of algorithms that you can choose from. So how do you choose? Partly it's going to be study. You're going to have to, take the class in it. You're going to have to work with it. But they also have this cheat sheet, which is really hard to read. I can probably zoom in on it, but basically this cheat sheet you can download will, what is it you're trying to do? What does your data look like? And it'll suggest which type of algorithm to use. And then you can always use a different one that's similar if you think you can get better results. And okay, so guess what? Anybody you have an Azure account? I've got a couple people. So a lot of people don't get an Azure account because they want a credit card. Even if you have an MSDN subscription, that's how I use it. I get 150 worth of credits per month that I can use. but I still had to give them a credit card. And sometimes it runs out before the month's out. You know, if I forget to turn a virtual machine off or something, it runs out, and I'm like, oh my gosh, now I can't use it, or I have to pay them. I want to use it. So this is what's really cool. Azure Machine Learning, if you go to this link, studio.azureml.net, you can sign up for an account for an Azure, what they call it, a workspace, without providing a credit card. And it doesn't count if you have another Azure account, you have so many credits per month, it doesn't count against that. I was really excited. So you can play with this. There is a limit to how much you can do. And I've played with it so much, I've almost reached the limit. So that's kind of a bad thing, because a lot of times you have a data set that you're uploading, and inside your model, or what's called an experiment, sometimes you make a copy of that data set because you want to do something else with it. So it seemed like you can have, is it 10 gigabytes? 10 gig, and you can run into that really quickly.
Well, and if you implement the web services, I found that the web services suck up a tremendous amount.
The web service does too.
Yeah.
And I never even realized. So there's other, if you need to do more, if it is for production, you could just sign up for a different level of account, and then you do have to pay. But for learning, this is really great.
The lesson is delete your old web services you aren't using anymore.
Delete your old web services. Luckily, I don't have too many of them. Yeah, you know, that's the thing. The class that I took didn't really mention that. And I just happened to just be clicking around and clicked on the settings and saw it, and I'm like, oh, I'm almost out of space, and I have to present on this.
Yeah, trust me, it'll tell you when you run out.
It'll tell you. Yeah, everything stops.
So does this still work like last year I hit, what was 30 or 60 days and then they shut it down?
This is separate from that.
Okay.
This is separate. So if you had a trial, this is complete. You can get this completely separate as long as you sign up for the free account.
Okay.
Yeah, that's what's great, because
I
I've
went
got.
about it the wrong way then, because I was like all disappointed because I got sidetracked with other stuff and then it ran out after the amount of days.
Was it this or was it Azure ML? Was it Azure ML or just Azure?
Just, I guess, the regular
Just the
Azure.
regular Azure with
Credit
virtual
card.
machines and
That's
stuff.
it.
Yeah.
Just go to studio.azureml.net. That's where you want to sign up for the account, and I've been using mine for over a year now.
Yeah.
Haven't paid a penny.
That's good.
And I've just been using mine since July. So that really hasn't been very long, but I don't, at least, you know, yeah, exactly. The URL, and it's on the previous slide. Down at the bottom, let's see. Yeah, studio.azureml.net. So it's on the bottom of that slide if you can see it. But yeah, you can, you know, it was different levels of subscription. I just said, I want a free subscription. And it hasn't counted against my other credits. It's really nice. All right, so we're going to have some demos. I love this little video thing because that's what it does in, I think it's so cute. But that's what it looks like in Excel. That's a little video from what it looks like in Excel. So that's where I got that. Okay, so the first thing I'm going to show you, there was a lab. I'm actually going to go through a part of a lab that I did. And in order to work with this, you have to have some kind of a program or something, send the information in. Send in all the features for a particular object, right? Send in the data. So this particular program, and I'll get all the code to Julie, this particular program basically, well, before we do that, let me explain what the data is. Let me go back to the slides for a minute. All right, so let's look at the data first. So the data were, let's say they gave a bunch of people these little slips of paper. And they, each person got 9 or 10 slips of paper, and we're told to write 0 to 9. Okay, and then they scanned those. They ended up with 3,800 basically scanned pieces of paper. All right, and the way it's kind of weird, but they ended up scanning it in until it had 1,024 pixels per digit. That's how they divided it up. But then they ended up just having a number for like 4 across and 4 down, 64 numbers. So the data is kind of weird, but I'll show you what it looks like in Excel. It's kind of weird because there's a number, there's 64 pixels. There's 64 pixels. However, each one has a number. It's not just like off or on. It's kind of weird. Each one of these represents a little 4x4 square. 16. So I'm not sure exactly what that number is. The number, it looks almost like the number of pixels that were filled in that little square. But we have a total of 64. And then over on the end, we have the actual digit that it was. Okay, so it could be anywhere from 0 to 9. All right, and those were handwritten scanned. So if I go back to the program, they're actually supplying this data, and then they're going to call the web service. They have to have a special key to get in. They have to have the URL to get in. And let me go ahead and kick this off. This is just a C# program. So I have a client here, and let's say I type in like that or click that, and then it goes to Azure, and it says, I've entered an 8. So that's really wrong. So it's not 100%. Let me clear that. Let me try again on 7. Let's see if it liked that one better. You entered a 7. So it's not 100%. And the other thing that's kind of weird is it says a 5. Oh. Let's try that again. This is not exactly the same original input that it had, a 3. It's really doing badly. It's not the same type of input that it was originally, those pieces of paper, which I have a feeling still 3. So I gave this talk in Kansas City on Saturday, and it got almost everyone right. So I'm not sure why I'm doing so poorly now. It's what? It's drunk? There, got the 4. So it's just got these 8x8, 64 different pixels, which are going to be off or on, and I guess this turns them into like a 16 in those numbers. So that's what I thought was kind of weird. But let's just talk about how that was built. So I'm in Azure Machine Learning Studio. There are projects. The projects are, let's see, if I click on a project, it doesn't really do anything. The projects are a way to organize things. However, I didn't really find them that helpful. You can create a project, you could add things to the project, but it didn't look like you could actually open a project. So I'm not really sure how great that is. Experiments is where we are actually going to try to create a model. We're going to clean up our data, and we're going to create a model and test it. Okay? The web services is where these things are going to be deployed. Notebooks are a thing called Jupyter Notebooks. So do you use Jupyter Notebooks? Nope. Okay, Jupyter Notebooks is a way that you can run Python or R code. So we can have a separate little program where we can run Python code and draw graphs and things. And data sets is going to be our data, and there's data sets that I've uploaded. There's also data sets that are samples, and then the trained models are the models that are actually deployed. These are the ones that we said, yeah, we're ready. And then settings is where I found that I'm almost out of space. I didn't know that till the other day. All right, so what I'm going to do is create a new experiment and go through creating that simple digit web service that I showed you the end result a minute ago. So I'm just going to say a new blank experiment. There's lots of tutorials in here. And when I first used this, I thought I had to get things right on these dotted lines. No, those things, as soon as you drag one thing over, those things disappear. But what you always do is start with the data set. So I have that CSV file that I showed you, digit recognition. We just had that open. And I can just pop it anywhere. And then that background disappears. Okay? I can click on this, right click, and I can visualize it. And what it also does, not only can I look at it, but it also creates little histograms of values, you know, so it creates histograms, I believe, just of what's turned, what has, what's not zero probably. And then there's some statistics over here and some more visualizations. So depending on what the data is, you might be able to just glean some information just looking at this in this first window. All right, so the next thing I'm going to do is grab it's kind of like a transform called edit metadata. This one's used a lot. Here's one thing that I kind of don't like. I can't give, like this edit metadata, I could have 10 edit metadatas that do different things. I can't give it a name, you know, which I think is odd. I can create a little note, edit comment, so I can say is changing digit to categorical, you know, telling me what it does. But then that kind of goes away unless I click on it and open it up. So there's no names, and I thought that was kind of strange. I feel like I could get mixed up on where to go. So all I'm going to do is just drag and connect. Okay, really easy. Now on this one, I have to do some configuration. So what I want to do here is take that last value. This is called the label. This is what we're trying to figure out, the label. And I'm going to tell it, hey, this is categorical. I'm going to make it a category, it's not a numeric value, it's categorical. You want to treat it like red, blue, green instead of 1, 2, 3, 4. We don't want to treat it like a number. Okay, so we've done that. And then the next thing we're going to do is add a split, because if you remember, I said you start training the data on a fraction of the data and test it on another fraction. So we're going to split the data into two. Just continue to drag here, and I'm going to split it into 0.8. And I also want it to be random, and I can also put a random seed in there. I'll go ahead and do that. But I want to have 80% of the data I want to train on, and 20% I'm going to test. I'll just put a random seed in there. Okay. The next thing I'm going to do is bring in a train model transform and add it over here. Notice this one has two different connectors at the top. So the neat thing is, if I try to drag this to the wrong one, I don't know if you can see it, but it lights up red and says, sorry, you can't do that. That's the wrong place. The data needs to go there. So that's kind of nice. Sometimes it keeps you from making a mistake. And I'm going to pick an algorithm, and I just know the answer here because it was in a lab I followed. I don't have any super secret knowledge here yet. Again, I'm still learning. I know it's regression because my problem is this is over here. I'm not seeing what my letters are. Okay. I know it's regression because I'm not finding out true or false. I'm trying to find, I'm trying to find a value, which one it is. And so I can drag that over here. Okay, and this is the pattern you're always going to have. You're always going to have a pattern that looks like this. The next thing I'm going to do is score the model. That's how I'm going to test it. And I'm going to bring that 20% over here. And I'm going to bring the results of the training over here. And also there's one thing I forgot to do. On the train model, I also have to tell it what am I trying to figure out. And I am trying to figure out the digit. Okay. So this is a pattern that you'll always see. Now, most of the time, it won't be this straightforward. A lot of times you'll have duplicate data. Sometimes you'll have missing data. Sometimes you'll have features that don't matter. And there's actually algorithms you can use to figure out which algorithms don't matter. Let's say you have 100 different features and you're like, well, that's way too many. There's some algorithms you can use and it'll tell you which ones don't matter. And you can get rid of those. If you don't really get rid of them, you can, ignore those. One of the labs I did was on airlines, on flight delays. Okay, so is a flight likely to be arrive late? And where was I going with that? There was a good point.
Feature reduction.
Huh? Yeah, feature reduction. There was something else. It was along the lines of, maybe it was because that was the one I did on my final exam, and I had a whole bunch of sections that looked like this that I just kept comparing. Okay. Oh, but again, you can, I know what it was. It was the duplicate data and the missing data. Sometimes the same exact flight, the same exact day was in the data more than once. Exact duplicate. Sometimes everything was there except it didn't show whether the flight was delayed or not. And so I could either get rid of those rows or I could just say it wasn't late. I could just pick something. So there's controls that will delete rows if you want them to, based on all or some of the columns, and leave one. So let's say there's 5 duplicate rows, you want to leave one. Or, supply a value if one's not there. There's a lot of different things you can do. All right, so then.
On this last, when you set the column to be digit on the train model piece, can we think of it as like digit is the output?
Digit's going to be the output.
Or you can have more than just one column be an output?
More than one column, I think you're trying to figure out one thing. However, more than one, you're just trying, I don't know that you're ever trying to figure out more than one thing. I haven't run across it. You're only trying to find out one thing usually. So, yeah.
Your recommended.
So in
Recommender might give you more.
TensorFlow, they do come with things where they tell you the percentage of the percentage that something that you're trying to find out using OCR or whatever it is.
Okay.
Is possible, like 96%.
Right.
Is yeah.
Right. You do get that. So you do get that a probability. Probability. So you get, but I think what he was trying to say, what if there's more things that I'm trying to figure out? I think with regression, you're only trying to figure out one thing, if I remember correctly. But it might be that I haven't run across enough examples yet in my journey here.
The reason you picked it is because this is a supervised training. So that means you've got a set of data that has the answer already in it, and it has to figure out what corresponds to that answer. And so the digit column is the answer key. So you have to tell it when it's training your model, this is the answer key you're looking for. And then when you go to score it, which Kathy's about to get to, that's when you don't necessarily let it cheat. You make it see how well it did. But what you're doing in the training is you're telling that algorithm, and maybe Kathy, if you click on the multi-logistic regression one. So you see on the right there's a bunch of parameters that you can put in that will change
Mhm.
how this thing evaluates and how it comes up with a different answer. And so that's what the training does, is it takes these numbers and then figures out, well, how well did I do? What are the results I need? And then when you score it, you see, well, did it hold up against something where I didn't change it?
And that's when I did the final exam, that's what I did. I took the same model, started playing with these numbers. Was it making things worse? Was it making things better? You know, makes things better up to a point, well, then I know where to stop. So that's exactly right. So we're trying to find out just what the digit might be on that 20%, and we can compare it to what it really was, and we'll know if we're
What
right
you
or not.
just said really helped me, although that
Okay.
regression thing blows my mind, but already in split data, you got the correct answer in the data column.
Right, because at this
And when it
point,
gets to score, it just compares that to what it guessed.
Mhm.
How did it get the correct answer in that 65th column in the first place? Somebody
Oh.
went through and said, oh, that's a 7.
right. They knew up front what it was.
Okay.
So just like kind of like the flight delay stuff, they have all this data that's out there. Well, then if I have a flight that's going to be tomorrow and I have most of this data, I can kind of predict, oh, it's St. Louis during tornado season, like the evening, there's a good chance that the flight's going to be late, something like that. Or the flight's in Charlotte, yes, it's always going to be late.
So I got confused. Is the 20 or the 80% going through the training?
80% is going through the training, and then we're going to test or score 20%. And again, we know the answer, but what the data scientist is going to do is spend a lot of time testing different algorithms, playing with the settings, until they get the perfect, or not perfect, but best. So where did this one go? The bad thing about this example is that the way we test it, where I'm just writing in those numbers, it's not the same as the data that it was tested on. And that, I think, makes it bad. It's almost done. It's on the last step.
Yeah, there's not too much fidelity when you're using your mouse. It's kind of like when you sign your name at the checkout.
Right.
How often does that signature look like your signature? I've gone up to put X's, there's no ML. Even
Yeah.
a machine learning algorithm will pick up that one, right? It's always accepted, just make a scratch mark.
And this seems to happen to me every time. I'm going to go ahead and recover the web page. I don't know if it's just me or what, but it seems like every time, the first time I run it, I have to do that. And once it's done, we can look. The nice thing too, if I would close this up and go look at it tomorrow, it's still going to show that it was run, and I can, at each step, I can look at the results. I can visualize the results at each step, and I can still do that tomorrow, unless I make a change. So what I'm going to look at is a scored model, and I believe it's got a lot of extra pieces. It's got a bunch of probabilities. Let's see, almost to the end. So here's the end of the data, right, where it is digit. And so it's got a probability for each possible digit. What's the probability? Here was a 2. What's the probability that we know it's a 2, but we didn't really tell the algorithm that it was. Here's the probability that it was a 0. Here's the probability that it was a 1. 88% chance it was a 2. I'm going to just look at these 2, 4, 8, 8, 9, 9, and scroll over 2, 4, 8, 8, 9, 9. So it did a pretty good job of figuring it out. Well, I don't want to go and eyeball every single one of these, so I can look at. Click on a column, but there's some other thing I can look at that's on the evaluate model. That's where I want to look. On the evaluate model, it gives me the accuracy and precision and recall, and I have definitions of what those mean, but they're difficult for me to understand or actually even say. But it's like the percentage of the number of ones you got right, how many did you expect to get right, blah, blah, blah. But anyway, you want those numbers. For each number, you want them, close to 1. And it's like overall accuracy, 96%. This is actually pretty nice to review here. I don't think I can get it to expand, though. So for the zeros, 96% were evaluated as zeros. 1.3 were evaluated as 2. 1.3 was evaluated as 4, and 1.3 was evaluated as 5. So if I look down this diagonal, I can see that they were almost, they were pretty close. They were always at least 90% correct. And that's the 20% that we tested. Okay, so the way that
those zero kept coming up 30 or something.
when I was doing it manually,
No, when you did your first demo.
right? It just is not as accurate.
In these results
Yeah, I think the problem is the original data was handwritten on pieces of paper, and it doesn't compare very well to this digit thing. So I've only got, is it 8 by 8, 64 pixels, and those were scanned in originally at 1,000 pixels. So I feel like it's not as accurate as it should be, just because I'm kind of not comparing the same thing. If I had pieces of paper that I could scan in, I think it would do a better job.
I guess what I'm getting at is so what zero was coming up 3 or 5 or something?
Right.
Does your results that you were looking at a while ago indicate that there was a probability for those 3s to show up occasionally?
Well, yeah, if I look at this chart, where did it go? It shows me that it's not 100%, but I think the reason that I had so much trouble with that little program is that the original data was these handwritten pieces of paper that they scanned in. It's not exactly the same thing as that little pixel. I think that's part of the reason, but it did work better the other day.
Am I misinterpreting it that if you went across the 0 row there at the top, theoretically you would see like a percentage under the 3?
Right. But again, this is that handwritten paper. So I kind of wish that there was a way I could just, scan in these handwritten pieces of paper, and I think it would work better. Anyway.
But anyway, you would expect to see like a certain percentage.
A certain percent, yeah.
3 for.
But it didn't. Yeah, it didn't.
Actually, the case.
Yeah.
Well, just like you'd expect there'd be something under 0 or 8 for 6s, but on this it said it's 100% on the 6.
Yeah, which was kind of surprising.
The other thing is when you do an 80-20 split, you have a very small training set or a testing set rather. And so your results can be a little bit anomalous depending on that particular 1/5 of the sample had nicely shaped 6s and 8s. If my handwriting had been in that sample, you'd see a lot more errors.
So I'm going to go ahead and show you how to deploy it. So the way you deploy it is you just click here and say predictive web service. And what that does is create the, it gets rid of that split. It just does the testing. And then you can actually come in here and make some modifications. So it gets rid of some things and then adds the web services at the top. And then I have to run it. So we have the predictive experiment. Then when it's done running, then I can deploy it. It's still running, still running. And so now I can deploy it. And once I deploy it as a web service, then it gives me lots of information of what I can do. So it gives me a key. And if I click, I'll show you in a minute on another one, the Excel, how cool that is. But if I click this request response link, it will actually give me code, it gives me a lot of information, all the information about the web service. It's in JSON, of course. Everything's in JSON nowadays. If I scroll down far enough, I will get to a section. There's talking about the different parameters. It's got to be here somewhere. There it is. So I have sample code in C#, Python, and R that basically is kind of the minimum that you need to call this service with the program. So it'll get you started with that. So basically just, you know, this is the data, this is where you got to populate it, and here's how you get the data back. You know, here's how you populate the data, this is how you send it, this is how you get it back. It's like that little program I showed you at the beginning, it had the gooey little interface, you know, that was extra. Okay? Well, that's pretty cool. Okay, I want to show you a couple more. Let me go back. There is a web service, one that's already set up on this bank credit. So let me show you what that one is very quickly. So on this one, we have a lot of information, and it is a classification. Can't get it to, I'm not getting it to scroll over. Oh no, I see why. I closed that. Okay, that's better. It's a classification model. Basically, I have a bunch of information, and I want to see if there are good credit listed on, so 1 or 0. That's what I end up with. But what I wanted to show you here is that I have a number of ways that I can, for example, eliminate columns. Okay? So almost everything you can do it a number of different ways. Select columns in a data set. So I can say, I want to exclude the housing column. And I did that with this select columns in data set transform. Okay? I could execute a Python script. So here's a Python script where I'm working with data frames. Okay? I say I want to eliminate some columns. I could do it in an R script. Here I'm eliminating some other columns. I could use SQL. Since I'm sure most of us know SQL in here.
I was going to say, thank God.
At least we know something. So the SQL Server can accept up to 3, it's not SQL Server, but it's a SQLite language. It can accept up to 3 inputs. It treats them as T1, T2, and T3. But you can join, you can do a lot of different things. So here I'm just selecting which columns I want, where previously I was telling it to, I don't want certain ones. Here I'm just saying, well, these are the ones I want. So theoretically, not theoretically, if I was doing this, I would have just chosen one method. I wouldn't do all of them. This is just an example of showing you that it is very flexible. Right? This one already has a web service set up, and I already have a spreadsheet. So if I go to the web service, which is right here. If I go to the web service, all I have to do is click on it and download this batch execution link right here, the Excel 2013 or later worksheet. You do have to have a add-in for Excel. There's an Azure Machine add-in that you need. So I'm going to save that and then open it and hope it works. Sometimes I have to do it 2 or 3 times to get it to work, which is aggravating. So there's my little experiment that I love that little graphic. But basically what you can do on here is you can use this to test other values. So I could start putting in other data in here and testing it against that. It's taking a long time. I'm going to come back to that because it could take 5 minutes.
So that would be where you would supply the different data set?
Right. You just could fill in values as long as they are the right, the right number of columns and the right types of values. You could just fill them in there, press a button, and it'll give you the answer. It'll just send those values via the web service out to Azure ML. Azure ML will send the answer back.
And so you had to have Excel 2013 or later and then go do an add-on? Where do you get the add-on?
I've got a link in the last slide. Let me take a look at it really quickly. It's still loading, so I'm going to just let that go and move on to the next thing I want to show you. In the experiment, okay, I want to show you just a join example. This one is not finished. This is that data about airlines that I was telling you about, flights that are, it's kind of weird. What's kind of weird about this data is that it doesn't have your typical airline codes, or your typical, not airline, but airport codes. It has, let's see, origin airport ID and destination airport ID, which I felt like was kind of weird. I would think everybody uses like STL or, whatever it is. Thought that was kind of strange. But anyway, there's also another data set that has the airport codes translated. So I don't really want to treat those as numbers, but I would like to know, the city and the state and the actual airport might make a difference. Maybe the state makes a difference. Some place where there's a lot of ice and snow, they might have more delays in the winter, okay? So to join that, there are several different ways. Like here's a way I can use this join transform, and basically I just have to launch this and tell it how, the origin airport from the first data set joins to airport ID. In the second data set, tell it whether it's a left join, inner join, what kind of join it is, and do I need to keep this extra column on the right, which I really don't need it. And then after that, what I'm going to do is use this edit metadata to take those columns that came back, city, state, and name, and I'm going to change them to origin city, origin state, and origin airport, okay? And then, just to show you I can do it, I'm going to use the SQL transformation instead and join. In this case, it's coming in, T1 is here, and T2 is here. So I'm just going to join T1 on T2 on destination airport ID, and I'm going to go ahead and give aliases. So I kind of like this better. Maybe it's because I write so much T-SQL, but I can give the aliases at the same time that I'm joining it. So I kind of like that. So I just wanted to show you how that worked. And let's go back and see if the Excel is happy yet. Oh, it's still not happy. Do I have it?
T1 and T2, is that just their designated naming conventions for the table 1 and 2?
Yeah, just table 1 and table 2. Yeah.
That really means the two different data sets.
It just means, where it came into, where it came in, which circles it was attached to at the top of the transform.
And there can be up to 3 nodes.
There can be up to 3. Yeah. So, yeah, table 1, table 2. And this thing is still not working, which is really sad. I'm wondering if I have another copy of it. I don't think I do.
Our production server looked all day today.
Yeah. The other day in Kansas City, one time before my session, it took about 5 minutes before it ever worked. But then when I was giving the actual session, it worked right away. So I have no idea. But basically, you can click a button, get sample data, that'll tell you what you need, and then you can change that data and click, get prediction or whatever that button is, and it'll send the values back. It is really cool. There's one more thing I want to show you, and that's the Jupyter notebooks. So if I look at this one, this data is data from a hospital where they had patients with diabetes that were admitted into the hospital, and they wanted to figure out how likely they were to be. I see you looking at I mean, hospital people like, what? So what they do is they are trying to figure out how likely someone is to be readmitted, which is really a big deal. It's really important. So so I have this data, and it has lots of information. The race, gender, age, weight, how long they were in the hospital, all kinds of information here. And so this Jupyter notebook is pretty cool. I can have sections where I have notes or information, and then I can have other sections where I have either Python or R code. So in this case, I'm just saying I want to see, these results. And so it's just explaining it to me. The other very cool thing, and there's a lot of code here. At this point, I don't know it well enough to write it myself. I have to go back and look at examples. But what we're going to do here is look at each piece of information and compare it to whether or not the patient was readmitted. So I have a histogram of each feature. So I can go in here, and even before we start playing with it in Azure ML, I can take a look at it and see if I can find anything that looks suspicious or looks like there might be some kind of correlation. So that's, and again, this was all with Python code. So that's a benefit there. And you can, these can be saved, and, you can have all kinds of information in these other sections. So this is, you can add, when you ever add a new section, you have to tell it whether it's what's called a markdown section or a code section. Okay.
How you spell your Jupyter's name?
All right, so that is the end of the long demo. If I could ever get that one to work, maybe before I leave it'll work. All right, where can we learn how to do this? I told you can do this for less than $1,000, or approximately $1,000. So there is, about a year and a half ago, Microsoft announced this big data science certificate, kind of like a certification program, a professional program. You can take all of these classes for free. If you want the certification, I believe you got to pay the fee, which is, right now it's like $99 per class. I think a couple of classes are free, but it ends up being 9 classes plus a capstone project, so 10 things all together. And at least at this time, at the most, it'd be $99 each. Again, it's out on what's called edX. edX is amazing. edX has classes from major universities like Harvard and Stanford. You can take some of these classes there. And some of these you can get college credit if you want. You can pay the money and do all the work. So the edX, this particular program everything is recorded and done by either Microsoft employees or people that they hired. It's all Microsoft for this particular program. And there's lots of other data science classes out there as well. So statistics was the hardest one for me. I took statistics decades ago. I was really good at it. But since I haven't really needed to use things like probability since I took that class, it's, kind of out of my brain. And so what I want to do, I don't think I'm going to take that statistics. I did pass it, but I didn't get a good enough grade in it to make myself happy. So I need an A in everything. So what I'm going to do is I'm going to find some other statistics classes and take another statistics class, probably after Past Summit's over, and then when I have some more time. And then I've got 8 classes done. I've passed 8 classes. My last class is the advanced Python class where I will be doing things like using the algorithms in Python instead of in Azure ML. And so I'm looking forward to that one, but so they're in a quarter at a time. You start a class, beginning of the quarter, you've got to finish by the end of the quarter. The last quarter, I did 2 classes, and then I got so busy with things, I'm like, I've got this one class, I'm just going to put it off to the next quarter. So I have this one class left, and then I can do the project in January. You only have 1 month to do the project. So the project can be done in like January, April, July, or I guess October. But I knew I wouldn't have time this month to do it. I have 4 speaking engagements this month and getting ready for House Summit. Way too many. But anyway, so that's out there.
And a new job.
A new job starting next week. Yes. When I made that decision, I didn't even know about the new job yet. So I just took a break for a couple months from learning this stuff. But maybe I am just a nerd. But you've heard of binge watching? Anybody binge watch on Netflix? I binge learn.
Everybody in my family.
Everybody in your family. I like to binge learn. You know, the introduction to Python class was super easy. Anybody with programming experience could get the introduction to Python pretty quickly because it was just basically how do you do loops? How do you do variables? How do you do this? How do you do that? So my grandson was playing video games at an arcade, and I sat at a table, even with all that noise, and did the whole class while he played for 2 hours. But it was pretty easy class. But anyways, maybe I'm just weird. That's fine. I like being weird. But it's a lot of fun. So if you like learning new things, I really recommend it. So here's some other links, and I'll get the slides to Julie, and also the lab that I did and the code that I ran. I'll get that to Julie. Not all the examples that I showed because, you know, you have to take the class and you'll do it. But that's the link to the main program at x.org. You can just even go out there and do a search. So the demo, I'm going to go ahead and send it to Julie. Microsoft gave a bunch of technical content to MVPs like me that they want us to present. And since I was so busy, I'm like, yes, I'm going to use Microsoft's content. I don't think it's cheating. They told us to do it. The problem is it's on GitHub. And I'm not really familiar with GitHub. I've barely used it. The problem is if you can't download just one little topic. You have to download the whole thing. And it's like, I think it's between 0.5 gig and 1 gig. And then you have to navigate to the piece you want. So I'll go ahead and give Julie that piece. You won't have to go out there, but you know, you're welcome to. I emailed Microsoft, the person in charge of that, and said, hey, I don't see a way to download just this section. Can I just let everybody have just this piece? And they said, no, they must download it from GitHub. So don't tell them that I'm doing this. What a pain.
You're going to go to the
I'm gonna
virtual class or whatever it was, right?
I'm just going to I downloaded the whole thing. I'm just going to give you the piece that we need for what I talked about tonight.
That's great.
And then also there's a link for the Excel add-on. So that's all I've got for tonight. Unless there are any other questions. But this is really fun stuff. And so I really encourage you to, yeah.
Is there a fast rule about the 80-20 percentage or
No.
there's a recommendation to
No.
try playing with that percentage?
There is not. When I was doing the labs in class, sometimes they did 60, sometimes they did 75, sometimes they did 80. It might depend. There's probably a rule out there that I just don't know yet, depending on how many rows are in the data and how many columns or features. So that only had 64 features and about 3,000 rows. So, you know, that's a decent number of rows. But again, it's all. I would think the more the better. I would think that if you want to make sure that you have a pretty good number on each side. But offhand, I don't know the rule of thumb. Anything else?
Thank you.
All right. Thanks a lot.
Everybody get it.
And Julie, I'll get the slides to Julie so you can get the links if you didn't get them. Let's see if that bank credit thing worked. Oh, I think it might have worked. Okay, the bank thing worked.
Yeah.
Okay, I am going to use sample data. And so that's some sample data. And then I know that the answer needs to start here. Oops, wait a minute. Let me do that again.
Yeah, I'll do that too.
Pardon? Let me do that.
It's like freezing in here.
Ah, I messed
Okay,
up.
if you bring up the.
Thank you. Project. Yeah, I finally got it to work, if anybody cares.
Good job.
So I just sat there. Eventually it connected. I'm not really sure why. And it worked.
Did you have to use a manual classifier for the first digits that you scanned in?
I didn't do it. It was data given to me from this lab, so I didn't do it.
Sure.
Yeah, it would have been nice if I did, because then I could have done the same thing. Right? It was basically, you know, given to me from Microsoft.
What about API? Was created. Was that also part of the lab?
Yeah, the little program. Yeah, that was the lab. Yeah, so I didn't do that. But bring this out here. I'm going to give. Oh, I need to stop the recording.
Does everybody know where they stand?
Stop sharing.
Before you share this problem, you want to.
Hey, do I have every evaluation?
Most people know by, I guess by December.